It kind of helps to know what kind of conics so we know how to solve the equation. So there's really, a bunch of choices here. So you might have like an ellipse. You might have a circle. Those two are going to look very differently. Very same, actually, very similar. The big difference is you're going to have something like this. Like you're going to have x squared plus y squared for both of them. For ellipse, you might have like ax squared plus bx, where a circle might be ax squared plus ax. In other words, if the coefficients are different, but it's plus, and both x and y are being squared, it's going to be an ellipse. If the coefficients are the same coefficients, it's going to be a circle. So hyperbola, the same side of the equation, you're going to have, the big thing is x squared minus y squared. You could have any kind of coefficient in the front. And parabola is probably the easiest to recognize. You might have like an x term plus a y squared, or a y term plus an x squared, but one of them's squared, one of them's not. They could have coefficients, etc. So those are the four situations, four types of conics we're looking for. So right away you see 9x squared plus 4y squared. So there's a plus. So I see it's going to be either an ellipse or a circle. 9 and 4 are different, so I think this is going to be an ellipse. Now we'll have to put it in the right form to figure out what form of an ellipse it is. So you just kind of complete the square here. And we've done this kind of thing before with circles, actually. So this shouldn't be too bad, but you want to kind of group the x terms together. So 9x squared minus 36x plus group the y's terms together, well, there's only one, equals 0. To complete the square, I really need like a coefficient to be 1 there. So I'm going to pull out the 9, not the GCF, just a 9. X squared minus 4x plus something plus 4y squared equals 0 plus something. So you're going to figure out what that something is. It's called completing the square. So half of 4 squared, half of 4 is 2, 2 squared is 4. So I'm going to add 4, but I didn't really just add 4 there. Really added 9 times 4, or 36. So I have to add 36 to both sides. This should now nicely simplify. So we have x minus 2 squared plus this is just 4y squared equals 36. Well, you know, for ellipse, we can't have it equal to 36. It has to equal 1. So we're going to divide by 36. Hopefully that goes into both of those numbers. I think it does. So this would be x minus 2 quantity squared. That really ends up being 1 over 4. So over 4. Plus this ends up being 1 over 9. So this would be y squared over 9 equals 1. Okay, so let's get a graph going here. So if we're going to graph this, just the next step of doing this, we got to identify the center. It's helpful sometimes to write that out. So h comma k is the center. So that would be positive 2 comma 0. So 2 comma 0 is our center. So everything kind of flows from there. This is an ellipse, so I'm just going to, underneath x, you're going 2 horizontally, so because that's our b squared. B squared is 4, so b equals 2. So I'm going to go 2 to the right, make a point, 2 to the left, make a point. The bigger number is a squared, so a squared equals 9, so a equals 3. So I'm going to go up 3, make a point, down 3, make a point. I'm ready to draw my ellipse. If I asked you to draw the focus, it would be c units away from the center on that major axis. I'm not going to do that. I'm just mainly concerned this lesson with solving the problem, identifying it, put it in the right form. Right away, we see x squared, y is not being squared. So this is a y equals, or sometimes we call it an f of x parabola. We're still going to have to complete the square with this one. What I like to do is keep the y term on the left-hand side. I like to keep the constant on the left-hand side temporarily. So we're to move these over by subtracting them. So we're going to subtract both of those. We get 12y plus 9 equals negative x squared plus, or sorry, minus 6x, sorry. I subtracted both those. So now you're going to pull out a negative 1 over here because we really need a leading coefficient to complete the square that's positive 1. So plus 6x plus blank is 12y plus 9 plus blank. And so let's see what goes here. So we go half of 6 is 3, 3 squared is 9, but I didn't just add 9 to the right-hand side. I really subtracted 9 or added a negative 9. So I'm going to add a negative 9. Oh, this probably could have been done easier. That's okay. I just see a shortcut that I could have taken. So we get 12y equals negative 1 times x plus 3, 20 squared. And last step would be divide by, last big step, we might simplify a little bit, is divide by 12. So we get y equals negative 1/12 times x plus 3 quantity squared. So let's see, the center, let's see, the hk would be, this is really like plus 0, so h is negative 3 and k is 0, so that's my hk. I know this is opening downwards. I like to sketch it just to kind of think about the focus and the directrix. So if I go a distance of c equals 1 over 4a. So 1 over 4 times negative 1/12, which is negative 4/12, negative 1/3, which is negative 3. So c is negative 3. So I'm going down 3, that's my vertex. Down 3, make my focus. Up 3, here's my directrix. And I'm going to go, c is negative 3, so I'm going to go twice that distance, so 6 units to the right. And I'm right over here somewhere, 6 units to the left, and you're going to make your focal diameter distance there and go for it. Okay, so we have 2x squared plus y squared. So again, this is going to be ellipse. So let's get all the x terms on the same side, y terms on the same side. So let's move that over. So we get 2x squared plus y squared minus 2y plus blank equals 1. So let's see, we're going to add half that number squared is 1 squared is 1. So I'm going to add 1 to both sides. I get 2x squared plus y minus 1 squared equals 2. Divide by 2. Get x squared. I'm going to write x squared over 1. It just might help us think about it. Y minus 1 squared over 2 equals 1. So my a squared is 2, which means a is square root of 2. My b squared is 1, which means my b is 1. Let's see, my center is at 0, 1. I'm going to go 2 units, no, 1 unit horizontally in each direction. And square root of 2 is about 1.4, so 1.4 above, 1.4 below, right about there. And you've got what type of conic is this? This looks like an f of y parabola. you can see that the x term is not being squared. So that's a giveaway. That's a parabola. So we get, let's see, so I want to kind of keep these terms on the left. I'm going to move these guys over by adding or subtracting them. So we get negative 8x plus 9. I always want the constant and the first variable term over there. So negative 4y squared plus 4y. Negative 4 I'm pulling out. So y squared minus y plus blank. And this is negative 8x plus 9 still. So what number will I add there? Let's see. Half of 1 squared is 1/2. 1/2 squared is 1/4. But I didn't just add 1/4. I added negative 4 times 1/4. So I added negative 1, or subtracted 1. So I get negative 8x plus 8 equals negative 4 times y minus 1/2 squared. I think that's right. Okay, so now I'm going to subtract the 8. So minus 8. Divide each term by negative 8. So we get x equals 1/2 y minus 1/2 squared plus 1. So if I'm graphing that, this is where you really have to be careful with h and k. So h is really the positive 1 there, and the k is 1/2. So 1, 1/2 is my vertex. It's opening to the right, which means my focus will be to the right of the vertex by distance of c. C equals 1 over 4 times 1/2. 4 times 1/2, which is 4/2, which is 2, which is 1/2. So c is 1/2. So go 1/2, well, it's tough to draw. 1/2 unit to the right, which is right about there. 1/2 units to the left is my vertical asymptote at x equals 1/2. And I'll go twice that distance, so twice 1/2 is 1, so I'll go 1 unit up, 1 unit down, make my points, and then draw my parabola. Last one, ooh, finally get, this almost looks like a circle because it has the same coefficients, but it's going to be a hyperbola because it's subtraction. So that's guaranteed there. So we get 10x, just kind of distribute minus 10y plus 1. So let's get all the x terms on the same side, and same thing with y. So x squared minus 10x plus blank. Plus, this is where it gets a little dicey here. So we've got minus, we're going to do this in 2 steps. So minus y plus 10y equals 1. So this one is going to be, I'm going to have to add, let's see, half of that number squared, half of that is 5. 5 squared is 25, so I'm going to add 25. So this first term, we pretty much got x minus 5 squared. Minus, we really need this to be in parentheses. So I'm saying minus y minus 10y plus blank equals 26 plus blank. So now I'm going to deal with the y's. The tricky thing is this was positive. Now it's negative because of the minus sign in front, and you really need that minus sign in front with hyperbolas. It gets a little tricky if you don't. Half that number squared is 25. So add 25. Oh, but I essentially subtracted 25 here, so I'm going to have to subtract 25. Wow. Okay, so we get x minus 5 squared minus y minus 5 quantity squared equals 1. So that's I mean, if you want to put it in the right form, you'd have it over 1 over 1. So it's really, it is a hyperbola. It's just, it's kind of a surprising problem. So 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3. There's the center. We go square root of 1 in each direction. So there you go. Make my dot box. It is a box. Sometimes it's a rectangle. Draw your asymptotes. Identify the vertices. This is horizontal. Reason is the x term is first. So the parabola looks something like this. You could figure out the other values, the c value or the focus points, but that's your parabola. That's your hyperbola. It's a horizontal hyperbola with a center at 5, 5 going off in each direction there. Okay, that's your screen cap.